So section 6.3.2, solving systems of equations, again the two weird cases that sometimes occur. So given the following system, we're asked to answer the following. So we've got the equation y equals 4x plus 3 and y equals 4x minus 2. So again, we should recognize in each of these equations that we have y terms, x terms, and constant terms, y terms, x terms, and constant terms. So we do know that these are linear equations, and so their graphs will be lines. So part A says to describe what the graph of each of these equations would look like. So let's number our equations here, 1 and 2. So our first equation is solved for y, so it's in the y equals mx plus b format. So our slope would be 4. And so the first one graph would be a line with a slope equal to 4, or we typically write the slope as a ratio of change in output to change in input. So we could write that as 4 over 1. So with a slope of 4 and a y-intercept, so again, if we plug in x equals 0, we're going to get y equals 3. Okay, our second equation also had just y terms, just x terms, and just constant terms. So again, it's a linear equation whose graph will be a line, and it's also in the y equals mx plus b form. So this is a line with a slope equal to 4 over 1 and a y-intercept. If we plug in x equals 0, we're going to get y equals negative 2. So we have two lines whose slopes are the same, but whose y-intercepts are different. So they have the same slope, same steepness, but intersect the y-axis in two different places, means that we have parallel lines. So these lines are parallel. So thinking about the graphs, what would the solution to this system be? So if we're thinking about the graphs, so we have one with a slope of 4 and it intercepts here at 3, and we have another one that has same slope, same steepness, but intersects down here on the y-axis at negative 2. So we have parallel lines, but to solve the system, we're trying to find an ordered pair that makes both equations true. It has to be on both graphs. Okay? And we can see from the graph when they're parallel that these two lines don't share any points. So these two lines do not share any points. Okay, there's no intersection, which means this system has no solution. So this system of equations has no solution. Okay, so if we were just asked to solve this system, we could use any one of our 4 techniques that we've looked at. So we've looked at the graphing method, we've looked at the table method, the substitution method, and now in this section, the elimination method. So using the graphing method, we arrive at the conclusion that they're parallel, so there would be no solution. Okay, but all 4 methods are supposed to lead to the same result. Okay, so what happens in this system if we try using the elimination method? Okay, so we have this system, y equals 4x plus 3 and y equals 4x minus 2. Okay. So again, we would like our coefficients of one of our variables to be opposite. So here we've got a positive y and another positive y. We'd like one of these to be negative. So let's just take this first equation and we're going to multiply this whole side by negative 1. And our property of equality says that we can multiply both sides of the equation by the same value. So negative 1 times a positive y, we're going to get negative y equals, and over here when we distribute the negative, we'll get negative 4x minus 3. And then this equation we're just going to leave alone. So we get y equals positive 4x and minus 2. So now, if we add the left sides of the equation together, a negative y and a positive y, we get 0 y. And over here we have a negative 4x and a positive 4x, so again we're going to get 0x. And a negative 3 and subtract 2, or adding a negative 2, however you want to think about that, we get subtract 5. Okay, so we're going to get 0 equals negative 5. Okay. And there are no values of x that make this true. So there can't be an ordered pair. Okay, if we can't even find the x, we can't find the ordered pair. So there are no ordered pairs that make the system true. So the system has no solution. Okay, the same thing happened when we tried to use the substitution method. We eventually ended up with all of our variables kind of were eliminated, and we ended up with a statement that was false. So there's no values of x that make this statement true, so there can be no ordered pairs x comma y that make the system true. So the system has no solution. Okay? Same conclusion that we arrived at thinking about the graphs. Okay, so now if we look at the other case, so this system, we've got y equals 4x minus 2 and 2y equals 8x minus 4. So again, if we think about what each of these graphs looks like, again, we have just x terms, y terms, and constants. So the graph of each of these will be a line. And this, again, is in the y equals mx plus b format. So this is a line with a slope equal to 4 over 1. And would have a y-intercept at 0, and if we plug in 0 for x, we get negative 2 for y. Okay. And on our second one, this one's not in the y equals mx plus b format, but if we divide both sides by 2, we're going to get y equals 4x minus 2. So again, we have to distribute that divide by 2 to each of these two terms. So now we've got, again, a line with a slope equal to 4 over 1 and a y-intercept at 0, negative 2. So now we have same slope and we have the same y-intercept. So two lines that have the same slope, and if they both cross the axis down here at negative 2 and have a slope of 4, pretty much have two lines that are right on top of each other. These are called coinciding lines. So these two lines are coinciding lines. And so again, we're after all the ordered pairs that they have in common. In this case, they share all their pairs that are on the graph of this line. Again, not all the ordered pairs in the plane. Okay, for example, this is not a solution. Okay, so it has to be an ordered pair that's actually on this graph. Okay, so in this case, we have all xy on the line y equals 4x minus 2 are solutions. So again, what happens to this one when we try to use the elimination method? So we started out with y equals 4x minus 2 and 2y equals 8x minus 4. So again, if we try to make one set of our coefficients opposites, so again, this is a positive 2y, so we're going to try to make this be a negative 2y. So we're going to multiply each side of the equation by negative 2 using one of our properties of equality. So we're going to get negative 2y, and when we distribute, we're going to get negative 8x plus 4. And this equation we're not going to do anything to. And so now, if we add the left sides of the equation, negative 2y plus 2y, we're going to get 0y. Negative 8x plus 8x, we get 0x. And a positive 4 minus 4, we get plus 0. So 0y is 0. 0 times x is 0, plus 0 is 0. Okay. This is true for all x. But again, we're not after just an x, we're after an ordered pair. So any x will work, but to be a solution to the system, that x has to work when it's plugged in to this equation. Okay, so all xy on the line y equals 4x minus 2 are solutions. So again, we have our three cases for lines. They either intersect in exactly one point when their slopes are different, or we have two lines that have the same slope and different y-intercepts, so they're parallel, then there's no solution. Or in this case, they had the same slope and same y-intercept, so they were coinciding lines, in which case we get all the ordered pairs on the graph of that one line, are solutions to the system.